Okay, so we're talking shells and payloads today. Let me share my screen. You guys can take a look what we're working on. So I think it's important that we have an understanding of where we are right now in this penetration testing process, right? We gave you like 4 steps yesterday, and it's important that we like kind of focus, like where are we as we're doing everything? I remember I told you it's not necessarily a very linear process. It's very cyclical, but you know, it's important we kind of have our bearings as we're zooming around through all these machines. So we had these 4 different steps. And we've been living almost this entire time in the information gathering section, right? All we've been doing is trying to find out as much information as we can about particular machines, mostly alpha now, but you know, eventually we're going to be doing this process on many machines. And we split up the recon phase into 2 different sections. We have the passive recon section and the active recon section. Now, the passive recon, again, is where we are not directly interacting with our target. We got the active recon where we definitely do directly interact with the target. Okay. Eventually, then we'll shuffle into gaining some initial access, right? Getting a shell, getting some way that we can execute commands on this machine. Once we have that, we're going to look for ways to elevate the privileges, get to run commands that we should not normally be able to, right? Get root or admin or system on the box. And then eventually, right, post exploitation, kind of go back to that recon phase. Now that you own the box, is there anything exciting there that you weren't able to see before? Maybe cleaning up after yourself, maybe adding new user accounts so that you can get back onto the box very easily and quickly, right? So where are we in this file transfers and payload section? We're really all over the place, right? We're going to be doing file transfers and building payloads throughout the entire part, right? After we've gained, to gain that initial access, to elevate our privileges, and afterwards, right, we're going to be doing more file transfers and payloads. So everywhere across this whole process, we're going to be doing file transfers and generating payloads and using those. So overview, what are we talking today? We're going to talk what are shells and what are payloads, what's the difference between them, get some nuance in this vocabulary. We will talk about a couple different kinds of shells. Then later on today, we'll talk about different payloads and tools we can use to generate payloads and stuff like that. So cool. First question I have for you is, what is a shell? What's a shell?
Command line interpreter.
Oh, okay. Command line interface, right? It's like anywhere you can put in commands, you get them to be executed. So I think shell, good answer. Or who was it that said that? Warren said was good answer. So let's take a look, right? Any kind of user interface that gives us access to the operating system services, right? We've already used a whole bunch of different kinds of shells before. What's the programming language we've been writing our commands in on Linux, on our Kali machine?
Bash.
Yeah, right. We already have an example of some types of shells or some types of command interfaces, right? We got the bash shell. We got Z shell, which is apparently the default one on the newest version of Kali. We've got regular old shell, right? Just SH. Bash is the newer version of that. It's called born again shell, but you have the original shell as well. You got different kinds of shells, web shells that we can use, similar to the one we've used on a CyberLab, right? Remember, you could use the web to access a shell. We get shells through other services as well. So I'll give you some examples of that. But the real important thing that we've all been using right now is we've been using interactive shells, right? You get to type things in, you get some kind of feedback out. It's not just you type in a command and it does it. It's you do type in a command, you get some kind of interactivity, right? So let's start categorizing these different kinds of shells. Now there's 2 different categories of shells we have here. And I have their specific definitions below. I'm going to read those specific definitions, even though I usually hate just reading out loud, but I think it's important we kind of take this slow. I'll give you an example of how this actually works. So we have a bind shell. That's the first kind of shell. This shell is the shell that's bound by the listener or bound to the listener. It says in most cases, you need to be the one you need to connect to it. And a reverse shell, well, that's just the opposite. The shell is bound to the connector. Okay. And in this case, you're responsible for catching it. What does this mean in English? Well, we have a very easy example to give you. I have a shell right here. It's my shell, says Matt. Hopefully it's not mirrored too badly, but you could see it says Matt. It's my shell. If you want to put commands into the Matt operating system, you need access to the Matt shell, okay? If it's a bind shell, it's bound onto me. I'm like stuck to me, right? You cannot get it unless, you rip it off of me. It's bound to me. So if you want to give me commands to the Matt operating system, you need to get out of your apartment and drive out to wherever I am and get to my apartment and reach out and connect to my shell so you can give me commands. That would be a bound shell. If, right, we do the opposite. Instead of the shell being bound to me, we do a reverse shell. If somehow you get me to throw my shell away and you catch it, and now you're holding on to my shell, you can give me commands to the Matt operating system. Right, so two different categories. One where the shell is bound, right? My shell, it's bound to me, it's stuck to me. If you want to use it, you got to come get to it. And the other thing is reverse, the opposite, where the shell, instead of being bound to me, I throw it away and you have to catch it in order to use it. Okay. Questions on these two categories of shells? Cool. We're going to go through and actually make some of each. Well, you guys will make some of each. And I think it'll make be a little bit more clear. Okay, so these are the two. Yeah.
I'm sorry to bother, but can you repeat it? I don't think I got it.
Cool. So if you want to give me, I say I'm a computer, you want to interact with my operating system, the Matt operating system. In order to interact with the operating system, you need a shell. Right? In order to interact with your Kali's operating system, you use your bash shell. In order to interact with the Matt operating system, you need the Matt shell. You need to actually, this is where you'll put in your commands on my shell. Okay. So, that brings the point. How do you actually get to my shell? Are you going to come to me and type on my shell so you can give me commands? Or do I throw my shell somewhere and you catch it? And then you put in commands that way. Does that make it more clear?
A little bit, yeah,
A
thanks.
little bit. All right. It'll be maybe more clear when you actually make both types of shells. Okay. But I think the easiest way to think of it is bind is bound to the listener. That means if you want to use that shell, you have to go, right, and to reach out to the listener. Reverse shell is the opposite. You have to catch it. And I'll show you both. Let's talk about payloads and how that's related. All right. So when you exploit an application, the payload is the actual code you want the attacker to run. So there's kind of two parts to our hack, right? It's actually getting the payload in there and then, creating that kind of payload. I want you guys to think of, a lot of the reconnaissance we're doing as like poking, like, checking are the windows open, right? If they're, maybe checking what type of windows they have, because we know this particular type of window has vulnerability or something like that. Right. So we're doing a lot of recon, trying to understand all of the stuff in there. Once we understand about our target, we can actually generate an appropriate payload. Usually this payload is going to be something in the form of, hey, why don't you send me a shell so I could run commands? We get the computer to do that, right? That's a pretty simple enough payload. The trick is, obviously generating that type of payload that the computer understands and then getting the payload to actually run on the machine. So let's use really simple example, really stripped down example of generating a payload with Netcat, right? Netcat, our favorite Swiss Army knife tool. We can use this -E option to send something. Let's go ahead and do an example. I'm just going to go right here to the Kali box, and we're going to connect to my the network, the PWK network. We're going to go to Firefox and revert a box. Let's see, what is it? Student. Where's my bookmarks? Oh, I feel like it should be here. There it is. So we'll go here. we'll do with our Debian client. Now I reverted it earlier, but I'm going to revert it again just to make sure that we're cool. And to get you guys in the habit of always reverting before you start using your machines. All right, so we'll let that cook over there. Clear. Let's open up two terminals side by side. Okay, both of them are just chilling as root at Kali. Once this is done, I'm going to connect to the Debian as student. That way we'll have two different machines to work with. And we'll set up a bind shell on one and connect to it. We'll set up a reverse shell on one and catch it. Okay, so here's the Debian machine. Let's connect to it. SSH student at 192.168. Oops. .206.44. Cool. Password is lab. Cool. So now we're student at Debian on the right side. And we're root at Kali on the left side. Okay. So I want to set up a bind shell. I want the shell to be bound on student at Debian. I want to use student at Debian's shell. Okay. So we're going to use NC to set up some TCP connection, right? Listen, verbose, don't use DNS, give it a port. I'm going to use port 1337 because we're a hacker. And we're going to use this -e flag and give it bin bash. Okay. I don't know what this -e flag stands for, so let's check it out first. NC-e flag. Oh gosh, this is not useful. Let's go to the man page.
I don't know. That does seem like an NC flag.
It does. My Google. So if we want to do better, minus Carolina. See if that helps. No. You still get NC. Whatever.
Linux.
Plus Linux. Fine, fine. We'll go down this. Excited. Here we go. But it's not giving me the -e. Oh, is it because it's reading this -e as without having E?
I straight up could not find like literally anything about the E. Oh, well, I guess I didn't look here. But like I found people using it everywhere, but like no one, like I couldn't find. Yeah, I guess there it is.
So that's, you bring up a good point. Not every version of NC is going to have this -e flag. You might even say or describe this as the ability to do this as a vulnerability. But it's useful for some things. But you're right. Not every NC is going to have this -e flag. But it is the one we're going to use just so I can demo it, make it very nice and easy for us. So this -e, and again, we have it from the SANS cheat sheet. We'll talk about SANS another time. Program to execute after connection occurs. So what we're saying here is use NC, listen, set up a listener, be verbose, don't use DNS, right? Listen on port 1337. When something connects, you want to connect that, whatever comes in, to the program bin bash. Okay, cool. Nothing's happened yet. Now, like I said, student at Debian has a bound shell. So I need to go out and connect to it. Right. So now I'm going to NC. NC, give it the IP address, 192.168, 206.44. 44 and port 1337, connect there. I don't know if I have to do -p flag, I forget. But it looks like we have some kind of connection, right? Let's see what happens if I type, who am I? Well, I'm not root at Kali anymore, I'm student. If I type host name, I'm student at Debian. I now have this bound shell from my root at Kali to, or from student at Debian to root at Kali, right? Confirm with an IP-C matter, right? You could see there's the IP address. Okay, this is a bind shell. This shell, bin bash, is bound to the listener. Okay, let's do it the other way. Do reverse shell.
What if you don't have, or what if you can't use E?
Then you got to do something else.
Gotta do some.
You
Okay.
got to do something else. If you can't use NC, but that you're asking good questions. I'll show you. I'll show you some, at least some things you could try. Right?
Oh, no.
But good. Yeah.
Can two people connect to that shell at the same time?
I don't believe so. I don't think so. I think you can only. Yeah, I don't think two people would be able to connect to that same port at the same time. Would they? Maybe.
No, I don't. I think NC is single threaded. So with your connection, like I don't think it'll spawn another thread to handle another connection. I think if you wanted to do that, you'd need to use SOCAT, I believe.
So the answer is maybe. We could find out. I could set up another. I could try and connect.
That's the best way. Let's try it and see.
Let's try it, right? This is what they say. So there we go. We got that. We're going to reach out and connect to it again. Okay, let's just open up another terminal. Split terminal vertically. Ew, I don't like it that way, but whatever. NC 192.168 206.44 441337. Connection refused. Is still here? Yeah. So it looks like you can only handle one connection at a time with NCAT. Good question. That's how we learn. Claps. Okay. And you see here, I have my crappy terminal. You notice I don't have a prompt. This is not the best terminal ever, but I do have a shell. All right, let's do a reverse shell now. All right. So in a reverse shell, we're going to, from our target, who is student at Debian, we're going to throw it somewhere. It's like when Matt had a shell and you want it, you somehow got him, you tricked him to throw his shell somewhere and you caught it. Like, ah, ha, ha, I got your shell, right? So how are we going to do that? Well, NC, oops, on this side, somehow get this machine to do NC-NV, give it the IP address I want to connect to, 192.168, what am I? And this, give that there, right? And what do we need to do? We need to give it a port number. Let's see, dash NV. Well, let's do 1337. And give it another dash E, then bash. Oops, Command L, Control Option L. Oh, I hit the wrong button. Come back. Okay. All right, cool. NC, don't use ZNS, be verbose, connect to this IP address, this port number, and use this executable on that side. All right, let's go. What did I do wrong?
The 206 machine's not listening.
No listening connection.
Hell yeah, you guys are gonna make this mistake so many times, so I want you guys to see it. You got to make sure you got a listener set up, right? Sometimes we spend so much time struggling to get the machine to do something like this. We're like, oh, it's not working. And you forgot to set up a listener to catch the shell. So let's do that. NC, LVNP, 1337, right? That's the port we're gonna listen on. Cool. Cool, right? Who am I? Again, I'm a student. Host name. Boom. And so this is a reverse shell, right? On this side, we're not listening anymore. We're just sending it out. We're just like, hey, reach out to this IP address on this port number and send them this program. And here, all we did was stay listening for it and had to catch it. Okay. So now you see the difference between bind and reverse shell. Okay. Your next question is probably like, what's the difference? Why does it matter to me? Because, you know, at the end of the day here, I still got a same shell. So why? Why might this matter? Why might this direction matter?
If there is a firewall,
Tell me more. I love it. Yes. Why?
Because when they send you the shell, you're skipping the firewall.
Tell me more. You're like right there, but I want to hear something, not something specific, but what about a firewall?
We have to go through the firewall to get to their shell if it's bound to them. If they send it to us, they've bypassed their firewall.
Yeah, you're really right on the right track here. If we think about like our perimeter defenses, right? It makes sense perhaps for you on the inside to reach out to a web server, right? You reach out to a machine on port 443. That makes sense, right? You want your users that are on your network to be able to use the internet. What you probably don't want is for people on the outside to just go out and be able to reach into your machine and open up or connect to any ports that are open, right? You usually are going to have some kind of firewall that'll stop you from doing that. In fact, if there's some kind of firewall, right? I use port 1337 just so you can see I'm clearly the elite hacker here, but you might want to try depending on like if you're super sure that your shells doesn't work and you might think, oh, there's a firewall perhaps blocking me, right? Maybe instead of using port 1337, I'll use port 80 because that'll look like regular traffic. And then here, I'll just listen on port 80. Oops, run that. And still same thing I get, right? I still have a shell. Right? I still have the shell, but you know, maybe now I would have been able to get through a firewall, right? Reverse shell is generally going to be the way we get our shells from now on. Right? They're just much easier to bypass things like firewalls. And it makes more sense, right? When we're guarding things, if we're like defending some city or something like that, usually don't care as much about people leaving so much as people coming right in. This is the idea here that I want you guys to get behind on bind and reverse shells and why we're going to use one versus the other. Cool. Cool. All right. So there we have our -E option, right? That's the example I'm going to give you for generating some payloads with NC. Very easy. Again, here's another example I stole from a different textbook, not yours. But here's the idea. You have two machines. I got attack box, which is off of .1, and I've got target, which is off of .2. If I'm looking for a reverse shell, I have my attack box listening on a port, have my target execute the NC command. With NC, my port that or my IP that I want to go to and the port that I have set up listening, and use -E to send over the program that I want to run, the shell that I want to run. Cool. Reverse shell. So we have other different kinds of reverse shells. We got gross looking ones like this. It's not super gross, I guess. But we have this bash reverse shell. So maybe if you could get the machine to run this, you would get a reverse shell. I'll show you what this looks like too. If you want to deconstruct what this is actually saying, it's running bash with the -I flag. I forgot the -I for. But then you have greater than and, so that's redirecting input to this input and error to /dev/tcp, which is, you know, just the file device TCP. And then you have a IP address and a port number. And then you see another redirection, redirecting the in to go out. So you're just kind of taking bash from one side, taking it from the other, and kind of connecting them together. Don't have to memorize this. I'll show you where you find it. Here you go. This is where you'll find it. This website here called Pentest Monkey. They've got all kinds of great little hacks that you might want to try as you are trying different payloads, things that'll fit in. Okay, I'll show you what that site looks like. And then we're not gonna do payload generation. We'll come back to that in the afternoon. So I forget who was it. Was it Steven? Or is it you that asked me what you would do if you don't have this NC-E on your target? Someone
Yeah.
asked me. Yeah, great question, right? You're at the next level.
Alpha, I don't think you can use -E in there.
Yeah, you can't. So depending on the box you get onto, you might not have the version of Netcat on it that has this -E flag, right? It might not be on that machine. So what can you do instead? Maybe try something else. Pentest monkey, reverse shell, cheat sheet. Here we go. Yes, you're gonna start getting these. Right, it's just I know that there's dangerous stuff here. That's what I'm going there for. Ignore. Okay, cool. So I would bookmark this, or at least be able to find it and Google it again, because it's super handy for whenever you find someplace on a machine where you can execute some kind of command. Well, the command you usually probably want to send it first is, hey, why don't you send me a shell? We work from there, kind of build off of there. And so here is the bash shell that I showed you before. Bash can send you a reverse shell. I'll show you this one. We'll try it out even. Copy.
How will this change with Kali using the ZSH shell now?
I think the new Kali, does the new Kali still have bash?
Still has
It
bash.
still
It still
has
has
bash.
SH.
I think
So-
most of the stuff is compatible.
Yeah, they're all POSIX compliant, so they still work together. But even still, as long as if bash is on the machine, you still just can send bash.
Yeah. So like Frank said, as long as one of these tools is on the machine, I could try it. So, right, if I'm on a Windows machine, it's not going to have bash, so I'd probably have to try something else. But if there is bash on the machine, this might be one of the first I try. I'll give you a hint and say, go ahead.
Is it safe to say that like most Linux machines will have bash, and then like do we have to do like command.exe for Windows?
Yep, you're absolutely right. Command.exe, yeah, that's what you would use in Windows. I will tell you, I have found in my experience, and I don't know why, this one is my favorite. It happens to work more often than not. This is my experience. But I do recommend that you try, depending on what you have. If you're like, oh, let's try bash, then try this one. It's nice and simple, right? Maybe you're in a Perl environment. If you're, Perl is another programming language. Maybe you're in a Python environment, you could try this, right? At the end of the day, they're all doing pretty much the same thing, right? Opening up a TCP/IP socket connection and transferring, right, some stuff from one program to the other program. So you'll see almost a lot of the same stuff, like take stuff from here, redirect it to there. Here, you'll see the one I just showed you before with NCAT with the -E flag. I'll show you this bash one just so that you have an idea of how these work. Copy. Paste. I'll do 133.8. 192.168. That's. I'll never keep memory. 119.206. 6. Okay. Looks fine to me. Let's just listen for it and see. LVNP 1338. Yay. Look at it, sent the whole thing. We even get the nice, a little bit better. Where am I? Oh, I don't know why it echoes. Oh, it echoes the command back. But here you go. Another different kind of shell. You can try all of them. Some work better than others. And again, there's no like one size fit all solution. A lot of this is just kind of trying and seeing what works. But like I said, this one tends to work nicely. So if you want to try an NCAT and you don't have -E, I would try this one next maybe. But there's a bunch to try. Okay. What else did I want to show you? I showed you Pentest Monkey. Showed you reverse and bind shells. I think that's enough. That's enough for us to start practicing with.
I had a general